Mark. As big as I can. Which is where the interior. All right, today I'm going to do a video on building sensors that I'm putting in and what the problem is, why I'm putting them in, and what I hope to gain from installing them. So this house, if you've watched any of the videos, is a little different than most, as you can probably see just by looking at it. It's a double studded wall, 8 inches of cellulose plus an inch of polyiso on the outside, and the inside is strapped. The wall is like 13 inches thick when it's done. It's also got a rainscreen on the outside. And then the ceiling is all 18 inches of cellulose, dense pack in the slopes and loose up top. So it should be a high performance assembly, whether it's the roof assembly or the wall assembly or the basement. So the issue is that as we slow the amount of heat flow through the building, we're also slowing the amount of moisture flow. So the moisture that's maybe inside of the wall is going to have a lot harder of a time drying out. A vapor retarder over this, it's going to be class 2, but a variable perm rating, which means that as this wall becomes moist, the interior vapor retarder is allowed to open up and allow more moisture out. The outside zipr sheathing is somewhere around 0.8 to 1.5 perm rating. So that's kind of on the border of class 2, class 3. So that's going to resist a lot of the moisture coming in, but it's also going to resist moisture flow out. So long story short, with high performance walls, we end up with a situation where we're going to be concerned about how much moisture is in there. So in order to combat that, we're going to put in sensors. This is one of the sensors. It's going to be buried inside of the wall. This one's going to measure temperature, relative humidity, and wood moisture content. So these 2 screws that go in here measure conductivity, just like a regular moisture meter, and then wirelessly transmit that information back to a gateway. So there's 2 different styles of sensors. This one here has probes for temperature and humidity probes, as well as moisture content probes. And then I got another one of those screw-in type sensors way up at the roof sheathing. So there's one at the roof sheathing, one at the insulation layers. So I'll have temperature up in that space. This one has 2 temperature sensors. So one's going to be halfway up the insulation and the other one's going to be at the ceiling plane. There's another sensor buried in the south wall on the inside corner of the bathroom, which is probably the worst case scenario for this particular wall because of the higher moisture load within the bathroom. So I wanted to measure the worst case scenarios. There's another sensor under the window in the north wall, which is the worst case scenario. there. That's going to give me temperature, humidity, and moisture content. And then there's another sensor in the basement that comes up into the wall. So this is one of the temperature and humidity sensors, and it's on the outside face of the south wall. And then there's another temperature probe on the inside face of the south wall. And then that's the screws that measure moisture content in the framing. Typically you'd screw that into the sheathing because that's going to be the condensing surface. But because of that foam, I'm measuring the studs, which is south facing under the window. And then for the north wall, kind of in this cavity here. Got another sensor in here with 3 probes. So there's a moisture probe down there. There's a temperature probe on the outside surface of the wall. So I'll measure the outside face of the wall. I'll be able to get temperature from the inside face and the outside face. So I can measure the delta between interior and exterior of the wall, as well as humidity, dew point, moisture content. The sensor mounted there, that's the transmitter, and then the probes go up inside that wall. That's the transmitter in the south kitchen wall, and the probes go up inside of that wall. This one's just on a regular piece of wood, and this is going to give me the interior relative humidity, temperature, and moisture content of this little piece of wood, which is going to be kind of a reference point, so I can reference this piece of wood to the exterior wall piece of wood. And down in the basement, this sensor transmitter goes outside. And I'll show you that out there and the reason why that's out there. This is the gateway. So you see there's no internet connected, but it can do Wi-Fi or cellular. I've got this one hooked up to cellular. And here's all the data. There's the sensor types, as well as temperature and humidity for all the sensors. I believe there's 13 sensors total in the building. All right, so this is the north wall temperature and humidity sensor up high. This is going to be behind the siding, inside of the 3/4 inch rain screen. This one here is going to poke down outside, so I'll have a reference for exterior temperature. And then this one here is a moisture content probe. So I pulled back the zip tape, and I'm right on a seam. So there's a shower behind this wall. I'm on the seam of a zip, and it's the north wall. So this is really the worst case scenario for the exterior. So this will be a good point to measure to make sure that our assembly is safe. But I'll have an exterior temperature reference because this is going to poke down. I'll also have a temperature between the siding and the sheathing to reference. So that exterior probe is behind this shower. And that's going to be important to be the worst part of the wall, or the worst part to measure, because there's going to be humidity changes in here that is going to try to force moisture through the wall and then hit the condensing surface on the outside. So we want to be able to measure that. Another variable would be the seasons and the temperature, humidity outside pushing moisture in. So in the summertime, when it's dry interior but humid exterior, the moisture flow is going to try to come this way and going to go inside of the wall cavity and try to dry to the inside. So by having those temperature sensors in there, we can determine what the moisture content is inside the wall and whether or not we're going to get to a dew point issue or moisture accumulation by measuring the wood moisture content. like I said, I did put a bunch of these sensors in reference points. So like the one in the basement ceiling is a reference point. The exterior is a reference point. But all of the other sensors are in worst case scenario places. I'm going to be trying to find a failure or ensure that I don't have a failure. So these sensors are really the only way to be able to monitor the building throughout seasonal changes. You wouldn't be able to get moisture probes in all of these places afterwards. You wouldn't be able to get temperature probes in all of these places afterwards. So this is really the only way to do it. And the reason why this is important is because there's not a lot of walls and roof assemblies like this to go remodel and examine what went right or what went wrong. This is the only way to be able to confirm that the assemblies are safe.